Welcome to Wisdom Planet. Wisdom worth spreading. Happy listening.
The book I'm discussing today is titled Aligning Humans and Machines. Published in June 2023, it is authored by Brian Christian, a best-selling writer known for his keen insights into cutting-edge computer science. We've previously reviewed his work The Most Human. In Aligning Humans and Machines, Christian tackles one of the most pressing issues in artificial intelligence today, ensuring that AI values align with human values. In simpler terms, it's about making AI more human-like. In science fiction, we often encounter scenarios where AI surpasses human intelligence, takes over, and enslaves humanity. Sometimes, humans try to impose various rules on AI, but these efforts don't always succeed. You might have heard of the 3 laws of robotics, proposed by sci-fi author Isaac Asimov, with the first law stating that a robot cannot harm a human. However, in Asimov's stories, robots, once in control, imprison all humans at home to prevent them from harming each other. The robot's logic is that humans are prone to conflict and violence, so the only way to protect them is confinement. Back in 1942 when this story was written, it was merely speculative fiction. But today, these concerns are no longer far-fetched. AI is increasingly integrated into our daily lives. Merchants recommend products to you, websites suggest videos, banks decide on your credit card limit, matchmaking services introduce potential partners. And AI even influences hiring decisions and bail determinations in courts. There's an intriguing analogy in this book. As AI becomes more powerful and widespread, humans resemble the half-baked wizards of fantasy novels, dabbling in magic without full mastery, often fearing the unintended consequences of their spells. We might intend to summon a small flame but end up with a fireball. Once we realize our spell is inaccurate or incomplete, we scramble to contain it, lest our wisdom conjures a terrifying dragon. So, how can we prevent issues in AI training? This book identifies the problems and potential solutions associated with different algorithms. In essence, there are 3 main scenarios, which we will discuss one by one. Let's start with the first potential issue. You might have heard about a major blunder by Google. In 2015, Google Photos introduced a feature where users could upload photos, and the site would automatically tag them using AI. For example, if someone uploaded a picture of themselves with a dog at beach, the AI might tag it as beach trip and dog, making it easier for users to search their photos. However, a software engineer testing this feature found a tag in his gallery labeled gorilla. This puzzled him since he hadn't taken any photos at a zoo. Upon clicking the tag, he discovered that all the photos were of his black friend. The engineer posted a screenshot on Twitter, commenting, "Google Photos, you messed up. My friend is not a gorilla." This incident caused a huge uproar online, forcing Google to apologize. Why did this happen? It wasn't because the AI had developed a consciousness and was deliberately being racist. Here's a bit of background. The most popular algorithms for training AI today include 3 main types. Google's image recognition uses a method called supervised learning. This approach is somewhat like how parents teach children by showing them pictures and naming the objects. This is an elephant, this is a zebra. Over time, the child learns to recognize these objects. The problem is, if parents only show red apples while teaching their child about apples, the child might mistake a green apple for a pear when they see one. Google's issue was similar. Because there are fewer black engineers at Google, the image library used to train the AI had fewer pictures of black people compared to white people, making the AI more prone to errors when encountering unfamiliar images. You might think this kind of bias should be easy to fix, right? In reality, correcting AI bias is much harder than it seems. Google couldn't technically solve this issue and ended up banning the gorilla tag altogether. Even if users upload actual gorilla photos, the AI won't tag them as such. This book, Aligning Humans and Machines, provides another example that highlights the problem. An American computer science student named Brandeis once worked on a class project to create a program that allows people to play hide-and-seek with a computer. While the coding process went smoothly, there was one issue: the robot couldn't recognize Brandeis' face because she is black. She had to use her roommate's face to complete the project. Later, when Brandeis attended a startup competition in Hong Kong, she saw a social robot developed by a Chinese company that also failed to recognize her face. As Brandeis noted, "On the other side of the world, I learned that algorithmic bias spreads as quickly as downloading a file from the internet." After graduating, Brandeis joined MIT's lab and worked on a project called Inspiring Mirror, an augmented reality mirror that gives users motivational visual effects, like transforming their reflection into a lion. Again, the results were impressive. But there was one problem: the AI still couldn't recognize Brandeis' face, so she had to wear a white mask to see the effects. Later, Brandeis tested facial recognition systems developed by Microsoft and IBM and found similar issues. These systems were 10% to 20% more accurate at recognizing male faces than female faces and light-skinned faces over dark-skinned ones. Why is this problem harder to fix than we might imagine? After all, wouldn't simply showing the AI more diverse images solve the issue? Let's look at a pre-AI era example to understand the core of the problem. In the days when movies were filmed on celluloid, Hollywood photographers used Shirley cards to calibrate colors. These cards featured a standard photo of a white woman named Shirley, an employee of Kodak. Kodak's influence made the Shirley card an industry standard. Back then, Kodak even adjusted its chemical processes based on white skin tones, which made it difficult for cameras to capture black people accurately. Although cameras aren't biased, when people calibrate cameras and film based on white skin tones, the equipment inherits that bias. Imagine a scenario where a black actor and a white actor compete fairly in front of the camera, with equal talent and looks. However, if the camera doesn't capture the black actor as well as the white actor, the black actor is more likely to be eliminated. Conversely, as cameras and film technology improved to make white actors look better, it created a cycle. The story takes a twist in the 1960s when Kodak film improved its ability to capture darker tones, not due to civil rights movements, but because furniture and chocolate manufacturers wanted better representations of dark wood and chocolate. Black actors and models benefited incidentally. In the AI era, every facial recognition system is backed by a vast image library containing tens or even hundreds of thousands of photos. These photos are the 21st century Shirley cards. Although we've moved from a single card to thousands of images, the underlying approach remains the same, selecting a few representative images to guide subsequent work. More images mean increased workload and costs. Developers have to manually tag the content of each training image before feeding them to the AI. Limited time and budget make it impossible to show the AI every image in the world, so developers choose what they consider representative. This selection introduces potential bias. This is the first type of AI bias, which can be described as bias arising from limited perspective. Can this bias be eliminated? The book argues that transparency in AI training datasets is crucial. Allowing others to scrutinize these datasets ensures they are truly representative. If the AI will impact many people, those people should know whether the training data considered everyone fairly. If we use a sufficiently comprehensive dataset to train AI without any omissions, will the resulting AI be free of bias? There is indeed such a training method. Earlier, we mentioned that the training method used in image recognition is called supervised learning. In other fields, there is another method called unsupervised learning, where vast amounts of data are fed to the AI without labeling each piece of data. The AI, after seeing enough data, will automatically discover patterns and relationships. If supervised learning is like a teacher instructing a student, then unsupervised learning is like allowing the AI to self-study. The AI is very diligent and will learn by researching a large amount of content on its own. Since this method doesn't require pre-labeling the data, theoretically, it can let the AI see an unlimited amount of data, avoiding the problem of limited perspective. However, new issues arise with this approach. The book provides another example involving Google, which seems to be at the forefront of AI development, leading to both achievements and problems. Google developed an AI that gathered vast amounts of gauge data from newspapers, magazines, and the internet, feeding this data into a neural network for the AI to find connections between words. Although the AI might not fully understand these languages, it learns the associations between words through automatic learning. It quickly discovered that Beijing is related to China, Moscow to Russia, and if asked about the UK, it would respond with London. The AI understood the relationship between capitals and countries through self-learning. Google's engineers added a feature to the AI, allowing it to perform addition and subtraction with words. Of course, this isn't exactly like mathematical addition and subtraction. For instance, if you input China plus river, the AI might answer Yangtze River. It can handle more complex equations too, like Paris, France plus Italy, and the AI would answer Rome. If you input king, man plus woman, it would return queen. This AI worked well until, 2 years later, some scientists playing around with it discovered some issues. When they input doctor, man plus woman, the AI returned nurse. Worse, when they input shopkeeper, man plus woman, the answer was housewife, and for computer programmer, man plus woman, it again returned housewife. In other words, this AI associated professions with gender. implying that certain jobs are inherently suited for men and others for women. This bias wasn't due to the AI developing a consciousness and consciously discriminating against women. The AI was simply finding associations between words based on the vast amount of data it was fed, which reflected human biases. So, can we erase such biases and prevent the AI from linking professions with gender? You'll find that this is much harder than it seems. Many large companies have developed AI systems to help screen resumes, including Amazon. Their approach was to show the AI resumes of past employees, helping it understand what the current employees are like. When reviewing job applicants' resumes, the AI would select those most similar to existing employees. Naturally, the applicants most similar to current employees are what the company needs. However, it was found that this system inadvertently introduced bias. For instance, if the current engineering team has more men than women, the AI would think the company needs more male engineers, leading to more female candidates being screened out. You might suggest modifying the system to exclude gender, preventing the AI from seeing the applicant's gender during evaluation. But resumes still include names, and if the AI sees an applicant named Mike and another named Mary, it might favor Mike. You might then suggest removing names as well. However, resumes also list interests and hobbies, and the AI might infer gender based on whether someone likes football or softball. Resumes also mention alma maters, and if a school is an all-women's college, the AI might pick up on that. Even the writing style can differ slightly between men and women, and while we might not notice these subtle differences, the AI can. The old saying, "birds of a feather flock together," applies here. With unsupervised learning, the AI can categorize people into various groups and treat these groups as high walls, excluding those who don't fit certain gender or ethnic profiles. This problem is particularly challenging because we need the uncontrollability of unsupervised learning. But we can't let it be too uncontrollable. The purpose of designing such algorithms is to capture hidden correlations in the data. For instance, if the AI discovers that software engineers who know some Chinese perform better, it might give bonus points to candidates who know Chinese during resume screening. This could be what the company needs because the AI has identified a trait that we might not have noticed. The AI can sometimes spot talent better than humans. However, these correlations can be uncontrollable, and while the company wants strong performers who can quickly integrate into the team, the AI might prioritize certain genders or ethnicities. Norbert Wiener, the father of cybernetics, once said decades ago, "The best way to ensure that machines achieve the goals we desire is to make sure that their objectives align with our true intentions." This statement is incredibly prescient today. I read another example in the book where human and AI goals did not align. In the 21st century, more and more American judges have been using AI to help make decisions, such as whether to grant bail to a prisoner. One of the most popular AI tools among judges is called Compass. Compass can score a prisoner from 1 to 10 based on their history, with higher scores indicating a higher likelihood of reoffending after release. In principle, the AI evaluates based on the criminal's past history to predict future behavior. However, in practice, Compass has shown significant racial bias. For instance, two drug offenders with similar cases might receive different scores, with the white offender scoring 3 and the black offender scoring 10. Where did things go wrong? Is the algorithm poorly designed? Some have pointed out that the issue lies in the past data. While the AI's goal is to predict the likelihood of reoffending, the data it uses can't actually capture that. You might argue that police records and court files provide this information, but those records only show how many people were arrested and convicted, not how many actually committed crimes. Therefore, what Compass predicts is not the likelihood of reoffending but the likelihood of being arrested and convicted again. This explains why similar cases receive such different scores for white and black offenders. In the US, police and courts are indeed harsher on black individuals. The book offers a striking analogy: if humans teach an AI to recognize apples but only show it red apples, the AI will develop a bias. Conversely, if someone consistently mistakes a lion for a cat, you can't expect the AI to accurately distinguish between lions and cats. This scenario increasingly resembles those imagined by sci-fi writers, where people hope AI will enforce justice impartially. But the AI inadvertently inherits biases. It seems that both supervised and unsupervised learning can lead to problems. Supervised learning can introduce bias due to limited datasets, overlooking unseen groups. Unsupervised learning, while avoiding this issue, can become uncontrollable, sometimes producing brilliant insights and other times wild inaccuracies. Even if it objectively reflects past human thoughts, if those thoughts were biased, the bias is hard to eliminate. Given these challenges, I wouldn't trust AI with judicial power. Fortunately, there is another method for training AI. Earlier, we discussed that there are currently 3 popular algorithms for training AI. We've already covered supervised learning and unsupervised learning. The third method is called reinforcement learning, where AI receives feedback for every decision it makes, such as earning points or losing points. Reinforcement learning is akin to a coach training an athlete. When the athlete makes a mistake, the coach immediately points it out and corrects it. This is the principle behind AlphaGo. This method seems more reliable since it is similar to how coaches train athletes, mentors guide apprentices, and companies train new employees. However, this approach also has potential issues, such as making the AI overly focused on actions while neglecting the underlying vision. The book provides an interesting example. The author's friend, an economist, was recently potty training his young son and wanted his young daughter to help. To incentivize her, he established a rule: every time she helped her brother use the toilet, she would get a piece of candy. A few days later, the little girl made what might be her first logical deduction and found a loophole in the rule. She realized that the more water her brother drank, the more he would need to use the toilet. So, she started giving him lots of water every day. This illustrates the potential problem with reinforcement learning. We've all seen similar situations in companies where employees diligently complete tasks, but these actions may not necessarily benefit the company or contribute to business growth. It's not always that employees lack responsibility. Sometimes even the bosses aren't clear on how specific actions relate to the company's development. The relationship between humans and AI is similar. Training AI to play Go, where the rules are clear, is relatively straightforward, but in more complex scenarios, we are often like the unclear bosses, unable to determine the relationship between actions and vision. So, what can be done? Computer scientists have found several solutions. One approach is imitation. Given the complexity of some scenarios, we can break them down into detailed reward and punishment rules, so we let humans demonstrate, and AI imitates. During this process, AI gradually internalizes some of our values. Autonomous driving is a prime example. It's challenging to teach AI how to drive using a set of rules, especially with complex road conditions. Instead, we have experienced drivers demonstrate, and AI learns from them. This is currently the best method for training AI in autonomous driving. Another approach is called inverse reinforcement learning. As the name suggests, this method is the opposite of reinforcement learning. You can think of reinforcement learning as a game where AI takes various actions like moving forward, backward, or jumping, and the environment rewards it with points. The AI's goal is to try different strategies to maximize its score, which might lead it to exploit loopholes in the rules. In reinforcement learning, the rules are fixed, and the AI figures out how to act. In inverse reinforcement learning, the AI observes others playing the game, seeing how scores change with different actions, and tries to infer the underlying rules. This way, we can see how the AI interprets the rules we've set and whether they align with our vision. If not, we can make adjustments. This provides a different perspective. As our goal is alignment, and looking at the problem solely from the human side might be insufficient. We also need to see how the AI understands it. Thus, inverse reinforcement learning is a new direction in artificial intelligence. There's another speculative approach. So far, the training methods we've discussed involve training individual AIs. However, consider how a company trains new employees. To make a team more efficient, the best training method isn't to enhance each individual's skills but to rotate positions, allowing everyone to understand each other's roles, challenges, and pressures. Some computer scientists have proposed applying this concept to AI learning, training multiple AIs and encouraging them to collaborate through interaction. Although this is still a hypothesis, if technically feasible, it could be a promising direction. Scientists have found that even 18-month-old infants can recognize when someone needs help. When scientists intentionally fell in front of them, the infants, despite being unsteady walkers, would wobble over to offer assistance. This is a highly complex ability, almost unique to humans, developed through millions of years of evolution to understand the importance of cooperation. AI might also become more human-like through such processes. That concludes my summary of aligning humans and machines. You'll see that instilling human values into AI is an incredibly complex issue. This complexity goes beyond just technological development and rule setting. AI also acts as a mirror, reflecting our own imperfections. We may not fully understand what our best qualities are, and we should also reflect on the biases hidden behind our everyday assumptions. At the end of the book, the author shares a piece of history that I think is a fitting conclusion for this discussion. In 1952, the BBC produced a program featuring a roundtable discussion with 4 scientists on whether computers could truly think. One of the guests was Alan Turing, often regarded as the father of computer science and artificial intelligence. During the program, Turing remarked, "Indeed, when a child is educated, their parents and teachers constantly intervene, stopping them from doing this or encouraging them to do that. But when humans try to teach machines, the situation is different. I've done some experiments teaching machines to perform simple tasks, and before getting any results, a lot of interventions are needed. In other words, machines learn too slowly and require extensive teaching." At this point, the host interjected, "Who is learning, you or the machine?" Turing replied, "I think we both are." That encapsulates the essence of this book.
Congratulations on finishing another book. Thank you for your support. Please subscribe to our Wisdom Planet audiobook channel. Like and share it with family and friends. Wisdom worth spreading and opening up a better future. Thank you and see you again.